12.3 is going to move us into actually doing probability and odds. Now it's important to know exactly what we're talking about. Probability is comparing successful to total. We usually are going to do a fraction, whatever our success is, over our total options, or we're going to represent our probability as a percent. So if you see the word probability in your instructions, you are looking for a fraction or a percent, success over total, however you define success, your desired results. So when 3 coins are tossed, what is the probability, fraction or percent? All 3 are heads. This is what I define as a success. Well, how are we going to figure that out? Easiest way for this is to make a tree diagram. So coin 1, I have 2 choices, heads and tails. When I toss coin 2, I could get heads or tails again, and I could get heads or tails again. When I toss coin 3, heads and tails, all the way down, because these are independent events. But by making a tree diagram like this, I'm sure that I get every possible combination. So what do I really have here? I have one option of getting heads, heads, heads. I have another option of getting heads, heads, tails. And I'm going to work my way through my tree listing all of my possible options. Heads, tails, heads, heads, tails, tails. Tails, heads, heads, tails, heads, tails. I'm right here. Tails, tails, heads, tails, tails, tails. Now you might think you could come up with all of these options on your own, but if you don't have some sort of a system, you're likely to forget one or two. You'll miss some combination. Now why do I need them all if I'm only after 3 heads? Because remember, my probability is my success over my total. I have to know how many different possible options there are. This is my total. So there are 1, 2, 3, 4, 5, 6, 7, 8 total. When do I get heads, heads, heads? That shows up 1 time. So my probability of heads, heads, heads is 1 over 8, which as a decimal is that. So we're talking 12.5%. When you toss 3 coins, because they're 3 independent events, 12.5% of the time you will get all 3 heads. Now sometimes we have combinations and multiple steps to our probability. So Roman has a collection of 26 books. 16 are fiction, 10 are nonfiction. He randomly chooses 8. This is going to be a key, chooses 8. What is the probability that he chooses 4 fiction and 4 nonfiction? So we have multiple steps right now. So his total number of books is 26. He's going to pick 8. And we want to know what's the probability of randomly picking 8. We're going to get 4 fiction and 4 nonfiction. So we have to go through a couple of steps first. So how do we define our success? Well, our success is going to be this. So that is a combination. That's from a previous lesson. So if I have, what are the numbers of successes that could happen? Well, I have 16 combinations of 4 for his fiction books, multiplied by 10 combinations of 4 for his nonfiction books. So that number, when you work it out, ends up being 1,820 times 210, which is 382,200. So there are 382,200 ways to pick 4 fiction and 4 nonfiction. okay, because order doesn't matter, so we use the combination. Now, how many total choices do we have? Okay, our total choices. Well, our total choices is this, picking 8 books randomly. What are all of the combinations of 8 books, regardless if they are fiction or nonfiction? So our total is 26, randomly choosing 8. Order doesn't matter. And when you work that out by its formula, remember that formula would be 26 factorial over 26 minus 8 factorial times 8 factorial. You get 1,562,275. So to find the probability of for fiction, for nonfiction, we take our success, which is that 382,200 number, all over our total options. And when you work that out as a decimal, you get 0.24, which is approximately 24.5%. So almost 25% of the time, if you randomly pick 8, you will get for fiction and for nonfiction, is what you've just found. Now we're going to switch gears and we're going to talk about odds. And this is huge. You have to know the difference between odds and probability. Odds is going to compare successful to unsuccessful, or unsuccessful to successful. If you add these two, you get the total. Now, probability is successful to total. So you always have to be careful what you're finding and how to move from one to the other. You have all of the numbers you need in odds to move to probability. You have all the numbers you need in probability to move to odds. So just read your directions carefully. So according to the U.S. National Center for Health Services, the chances of a male born in 1990 living to be at least 65 years of age are about 3 in 4. Keywords here: living, 3 in 4. So this is the probability of being alive, which is 3 out of 4. For females, the chances are 17 and 20. So for women, the probability of being alive is 17 out of 20. So what does that really mean? If 3 out of 4 are alive, that means 1 out of 4 are dead. If 17 out of 20 are alive, that means 3 out of 20 are dead. So remember, this is, the top number is alive because that's our success, and the bottom number is total. Now, read carefully here. What are the odds? So we are going to switch to whatever our success is defined as, to an unsuccessful. Okay, that a male born will die before the age of 65. So if our probability for men was 3 are alive and 4 are total, our will die is our success, and alive is our unsuccessful. So out of those 4, 1 has died and 3 are alive. Those are your odds, 1 to 3. For women, you're going to go through the same thing, that she will die. So our odds are successful is that they will die. Our unsuccessful is that they are alive. So if 17 are alive out of 20, that means 3 died and those 17 are alive. So 3 out of 17 are your odds that a female will die before. So 3 to 17. Now notice, if you add those, you get the total, okay, which is 4. Again, if you add successful and unsuccessful, you get the total. which is 20 in this case. So you can always check that you did it correctly. Now we're talking about probability distributions in this slide. So we're going to use the graph to determine which outcomes are least likely. So that would be the lowest probability. What is that probability? So use the table to find the probability that the sum equals 11. So the probability that the sum equals 11 is 1 out of 18. Oops, I skipped number 1. We'll just finish this one. 1 out of 18 is the probability. What other sum has the same probability? The sum of 3. If we go back to A, use the graph to determine which outcomes are least likely. If we look, our probability of least likely happens on our far ends. And the probability is 1 out of 36 that you will get a sum of 2 or 12, because those can only happen in one way. Some of the other probabilities have more than one die combination that would happen. Part C, what are the odds, notice we switched, of rolling a sum of 5? Well, here's my sum of 5, so the probability of sum of 5 is 1 over 9. So it is 1 success out of our total. So if I want the odds of a sum equaling 5, then it happening is still my success, but how many times doesn't it happen? 9 minus 1, it doesn't happen 8 times. So this is my success of rolling a sum of 5, and this is my unsuccessful, my failure of rolling something other than a sum of 5. And that is it for the 12-3 lesson.